All right, so here I'm logged into the RX side, or what is actually the access point in this case. And on this tab, this is the TX side. Whoop, let me make that bigger. I think those fonts are the same. No, one more. Let's get one more there. Yeah, one more. Okay, those fonts are the same now. So here, I'm already running an access point. So let's do, wonder if any of these, no. Spectral scan, I always forget the range. It is 897 to 937. And here, the wireless is disabled. So that access point should hear absolutely nothing because there's no interference source and there's no client trying to connect to it. And indeed it does hear nothing. Everything's 95-ish in terms of the noise floor, so let's kill that. Over here we can do a similar spectral scan. And range is 897 to, what is it, 937. And this is of course hearing that access point as it's beaconing. Okay, so that's a pretty strong signal coming in. A peak of what, minus 38? So the attenuation in the system is roughly 20 plus 30 being 50, plus another 3 dB for that splitter combiner thing. So 53 dB. And what is this transmitting here? The TX power. Where's my TX power? There we go. Plus 13 dBm. Now I don't know how accurate that is in terms of TX power, but let's see if that makes sense here real quick. So we had a signal of minus 38 and we want to add 53 to that. Minus 38 plus 53, so that should be plus 15. So that does actually make sense. Maybe off by a couple decibels, but pretty close. So the math says this is actually transmitting plus 15 dBm, not plus 13. So close enough. I will take this as a good spectrum rating. And what you can see is happening here, even though the modem is transmitting in a much narrower band of only 5 megahertz channel size, this is just spreading that received power everywhere. So this is the problem with these. So let's get these guys connected. So I'll just enable this interface. And yep, it's connected. Good. And hopefully we have some IP addresses. Yes, we do. And we should be able to ping, I believe it's 52.1 on the AP side. Yep, there we go. 6 millisecond ping times. Okay, now this is on the transmit side. So let's do a bandwidth test to 192.168.52.1 direction transmit. And this is without any interference whatsoever. Now that's surprising, the fact that it's jumping up and down like that. I would not have expected that from a fully enclosed coaxial system. Oops. Let's see what it thinks of the CCQs and such. Where are those things here? So TX rate is 4.8 megabit, RX rate is 9.7, good. And okay, signal strength received is minus 20. Whoa, okay, so that might be why, because this is way too powerful. So while this thing is transmitting at 13, this one is not set to do that. Yeah, this one is just set for 1 watt default, so that's a little strong. Let's change that. All rates fixed. TX power 13. Should reassociate, yes. Okay. Let's rerun the transmitter. There we go. So previously it wasn't able to exceed 5 megabits, but now that the power is lowered, it's doing 10 meg, which I believe is the max for this mode. Yeah, there we go. 16.2 megabit is the maximum signaling speed at 5 megahertz bandwidth. It hasn't jacked the TX rate on the AP because it doesn't need to. The ACK frames don't take that much. Where's the CCQ? Okay, signal strength minus 33. Yeah, that's good. And TX signal strength minus 31. So we're sort of symmetrical within 2 decibels. Ah, there we go. RX CCQ is 100%. TX CCQ being 40, I think, is just an artifact of the way they collect stats here. So if we did this the other way, or even bidirectionally, let's do both. There we go. We're transmitting 4.8 meg and receiving 4.7 meg. So it's sort of symmetrical. Yeah, both of these rates negotiated to 16.2, and both CCQs are 100%. So that basically means we've got no retransmits. Everybody's happy with the frames that they're receiving. Okay, this looks nice and stable. So now, let's see what happens when I click enable on that interfering signal at minus 41 dBm. Ooh, interference on. Still transmitting at 4.8, receiving at 4.7, so that's good. CCQ staying steady. TX and RX rates steady. Okay, this is looking good, but on the flip side, we're working with signal strengths of minus 30 whatever dBm, right? So maybe a little more realistic is let's go down in signal power a little bit. So right now the signal power is 13. I believe the lowest I can go is 0 and 1 through some previous measurements. 1 corresponds to, oops, corresponds to a significantly higher power level over 0. 0 is a nonlinear decrease. TX power equals 1, meaning that if you're diddling with this TX power 1 decibel at a time, that is a linear relationship. It's true in terms of what's seen on the port versus what you type for every single decibel increment up until you go from 1 to 0. And once you do that jump, it's a much more significant change. All right. Let's see what we got. Stats. Okay, so right now we've got a signal strength of minus 47 dBm, which is quite a bit lower than the 33 we're working with, but still really strong in terms of free space behavior. So this should not be getting too badly affected by that interfering signal. Let's see. Print stats, interval 1. And yeah, you see both directions are 16.2, CCQ is 100, so I'm guessing we're going to see 4.7, 4.8 here. Yeah, there's no difference here. Okay, let's drop to TX power 0. Oops. 0. Let's monitor that registration table. If anything actually registers. Yeah, it says it's connected. Oh, there we go, just took a while. And let's rerun that bandwidth test. It's renegotiating now. 14.6, 16.2, okay. And our CCQs are again 100%. And now the TX power is 53. So you see that was a very non-linear drop. We went from 47 to 53 in a single decibel step. Decreasing below 0 doesn't have any effect on TX power at all. Okay, well, it doesn't seem to be interfering with minus 53 signals, but then again, in the real world, minus 53 is a very strong signal. So let's add some more attenuation into this game and see if we can actually reproduce this around minus 70, minus 80, and so on.